Okay, class. I decided to go with this one. On the screencast because letter C has a little bit different of a setup, and I don't want to frustrate you by having you not figure out what's going on. The problem is this: we start off with HF on one side, and it's going to do exactly what we've seen before, where we get H plus and F minus like this. The problem is that we're not mixing. We're mixing like 50 milliliters and 125 milliliters, and the concentrations are different. So that means we're going to have to go back to moles. You guys know that moles is equal to whatever the concentration is times the volume. Okay, so we're going to have to go back and find the number of moles that we're going to start with, and then we're going to add up the volumes, then find the moles, add up the volumes, and then that's milliliters. So we're going to, anytime I use volume from here on out, I'm going to use liters because I'm going to have moles. So the first thing I do is I multiply 125 or 0.125 times 0.050 as my first way to find moles for HF. So let me just show you this, what it looks like. That's liters times the concentration, like that. All of this needs to be moved over here. No, that's not what I want. And then what that equals then in moles will be 6.25 times 10 to the negative third. In other words, when I do this, I get that. My H is still 0 because we're not messing with the hydrogen ion at all, but the F though, the F minus, the fluoride, that's according to that. So again, this is going to be 0.05. That's what this is in liters. 0.05 liters times 0.1 for that, which means 0.0050 moles. So these are moles and moles. And what we're going to go with is we're going to assume that however much of this changes, again, typically we do concentration for initial change in equilibrium, but because we're going to have the same volume for each one, when we get to the actual, you'll see later on. I'll make sure it's obvious. I'll show you what's going on and why this works. This is x because this is minus x, and plus x. There you go. So that's 0.0050 bonehead plus x, like that. We can get rid of the plus x here and the minus x there because my Ka for this is, where's my Ka, is 6.8. You can get this in the back of the book, Appendix D for hydrofluoric acid, and it's times 10 to the negative fourth. But that all equals hydrogen ion concentration times F minus all over HF. When we plug that in, I get 0.00 like that times x divided by, now here's the part. To make this a concentration, I would divide all of this by 0.175, and I would divide, that's 625. I would divide that by 0.175, the volumes. I would divide both volumes, but because they're both the same, that just cancels. So I don't have to worry as much about that. That's why in this fraction here, if I'm dividing one of these, if I'm dividing one of these on top, the numerator, I'm dividing both of them by 0.175, and then I would divide this by 0.175, and because we're doing the same thing on both sides of a fraction, or top and bottom of a fraction, it doesn't matter. So here's what I got for this now. I got x equaling. This is the x I'm looking for. There's the Ka value, and when I solve for x equals, what I get then, where am I at here, is 8.5 times 10 to the negative 4 for my hydrogen ion concentration, which means pH equals negative log of the hydrogen ion concentration. Okay, so that equals then 3.07, like that. Okay, that's it for letter C. Continue on with your work. Hope you if you have questions, bring them to class or message me.